Okay, so lesson 5, solving word problems. This is our last lesson in this unit. And for some of us, the word problems, the issues are actually probably going to be about language. So we're going to do our best. And my focus is always on skills in this course. But it is important for us to be able to translate the English language into mathematical language. So in this unit, we're going to work on some problem-solving strategies that can be used in many different types of problems. Why do students struggle with word problems? Well, there might be a translation issue, right? I know some of you don't have English as your first language, so that can be confusing and it can be challenging. So I understand that, and we're going to do our best to kind of work with that. Sometimes the order of information is mixed up. Okay, so it gets hard to kind of clarify that. Sometimes it can look confusing, and there might be extra information. So it's hard to kind of sort through what information we need and what we don't need. And I admit, sometimes you're going to run into the situation where there's extra information and you have to kind of sort through it. So we need to think of some strategies to start solving a word problem. Some you can highlight information. You can underline keywords. You can check your solutions. Does your solution make sense? If you take it back to the word problem and see, does it make sense with that answer? You have to read carefully. And you have to take your time. Okay? So, what are some words that are synonymous with the following? So sometimes you have to kind of translate. So addition can be sum, plus, and, okay. Subtraction could be a difference, could be minus, less. Similarly, addition could have the word more, right? There were 5 more than what they started with, okay, as opposed to 5 less than what they started with, okay? Multiplication, you might have times. Division, divided. Trying to think of some other words with division. And in the class, we might come up with more of them because it doesn't always have to be just about which ones I come up with, right? So I'm going to, think, and we might come back to this list in terms of that. But let me just see, because I know I do have a list somewhere. And I want to make sure that I get all of these for you. I have a list right here. Equals could be is, right? Same, total. Multiplication, we could say product. We could also say multiply. We could say doubled or tripled. Right? Those are words that would work, right? Divided, we could call it it could be called a quotient, right? Or split into groups, or halved, right? this we could, x to the power of 2, we could say squared. Power of 2, I've just said it, right? Okay. Times itself. Right? Lots of different ways that we could say this, right? Again, addition, you could also say increase. And subtraction, we could say a decrease, right? Because we're talking about something getting smaller. So this is might be getting larger and smaller, right? We don't know. Okay, so there are lots of different words out there. It's important for us to kind of really slow down and think about those words. Having this vocabulary, however, is useful. So it's useful for us to have these words and think about different ways we can express them. So we're going to start translating some word sentences into math sentences, equations, or expressions. These aren't necessarily equations, they are also expressions. Okay, it says, the sum of a number and 10. So we're talking about a sum, we're talking about addition. So if we call a number x, it would be x plus 10. Okay, whenever they've given you that, like a number, think of it as x. Let x equal that number. Maria's age 6 years from now. So if Maria's age is m, and 6 years from now, it'll be m plus 6, right? Or you could say x plus 6. Doesn't have to be m, it could be an x. The product of 6 and a number is added to 4. So the product of 6 and a number could be 6x, and we add that to 4. Okay? 3 less than a number. Well, if the number is x, and we want 3 less than x, we would subtract 3. Half of a number is added to 12. Well, to get half of a number, we would go x divided by 2, and we add that to 12. Twice the sum of a number and 8. So, if we have the sum of a number and 8, that would be x plus 8. If we want 2 of it, twice of it, would be 2 times x plus 8. A number is decreased by 2/3 of itself. Okay, so decrease means subtraction. So x minus 2/3 of itself. So 2/3 x. Tricky. Jean's age in a decade. Well, how many is a decade? It's 10. Jean's age, we say, is x. So x plus 10. So often the translation can be the hard part, and it's a matter of finding a way to write that so that you can get it. Okay? Let's try writing a number sentence or an equation. Now this really will be an equation, not just an expression. The ones we just wrote were all expressions given a word sentence. So, for example, the sum of a number and 12 is 100. So looking at this, we have a number, which is x. We're going to use a sum, which would be plus. We're going to add it to 12, and our solution will be 100. So x plus 12 equals 100. Now we don't have to solve these right now, we're just writing the expressions out. So you're going to try the next two. 5 more than 2 times the number. So pause that, try it, and then press play. So we're back. So we've got 5 more than 2 times a number. So our number is x. We have 2 times x, and we want 5 more. So 2x plus 5. Okay? 3 times the sum of a number and 8. So let's see. We have a number plus 8, and we want 3 times that. So we have to be a little careful with translating that. Because it's 3 plus 8, we have to put brackets around that sum. This is all together, and then times it by 3. Okay? Again, the hard part is translating. Now that we've spent some time solving an equation and translating word sentences, we're going to combine them. We know how to solve an equation. We've done a little practice translating. We're going to do both here. Okay, so first thing we're going to do is translate, write our equation, and then we're going to use our skills at solving equations to find our answers. So here, 9 more than a number is 33. So we have 9, and it's more than a number, and it is 33. So it equals 33. 9 more means that we're adding. So we have our number is x, and we're adding 9. Now we would solve this. Well, let's think about how we do that. We've added 9, so we're going to subtract 9 from both sides. So we're going to get x is equal to 33 minus 9, because that will cancel out. So 33 minus 9 is 24. Okay, therefore, the number is, 24. I think I said 34, but I wrote 24 down, and that is correct. Okay, and you'll notice that word problems, we always want to write a sentence answer. I know I ask you mostly multiple choice, but if you ever did have to write it out, you would write a sentence. And this 3 little dots means therefore. Okay? All right. Let's translate the next one. 8 less than 7 times a number is the same. So that's the equals. So let's see, 8 less than 7 times a number. So 7x minus 8 is the same as 4 more than 3 times the number. Woo! So 4 plus 3x. It's the same number. So they're both x's. All right, now we're going to find the number. Now we have things on both sides, but just like we always do, we're going to just follow our procedure. So I'm going to add 8 to both sides. Okay. So when I do that, I'm going to get 7x equals, what's 4 plus 8? Well, it's 12 plus 3x. And I'm going to move that 3x over, so I'm going to minus 3x from both sides. So I'll get 4x is equal to 12, divide both sides by 4, and I'll get x equals 3. So therefore, the number is 3. Okay? Alrighty. Now, here's some problems where we have more than one unknown. Okay? What does the word consecutive mean? Consecutive means, it means in a row. So consecutive numbers would be like 1, 2, 3, 4. So if you can see, they increase by 1. Okay? So here's a problem to solve. The sum of 2 consecutive numbers is 23. What are the 2 numbers? Well, we have to think about that. If we say the first number equals x, then the second number will equal x plus 1 because they're consecutive. They're in a row. Okay, now it says the sum of two consecutive numbers is 23. So if I have two consecutive numbers, so I've got x and I've got the sum, so x plus 1 equals 23. This is my first number, x, and this is my second number, x plus 1. Now, there's no factor around this bracket, so technically I can unwrap it, and I have x plus x, which is 2x plus 1 equals 23. And now I'm going to solve. So I'm going to minus 1 from both sides. So I'll get 2x is equal to 22. Then I divide both sides by 2, and I'll get x is equal to 11. Now, I know that the first number is x, so my first equals 11. My second equals 11 plus 1, because it equals, if I look over here, it equals x plus 1, right? So my second number is equal to 12. And I can check that. Does 11 plus 12 equal 23? Yes. Are they consecutive? Yes. So therefore, the two numbers are 11 and 12. Okay? So checking them, whether you check it on paper or mentally, is always a good strategy. Okay, the second of two numbers is 7 times the first. Now this one is not consecutive numbers. So I have my first number equals x. Second number is 7 times the first, so it's 7x. Okay, their sum is 32. So x plus 7x equals 32. Ooh. Add those together, I get 8x equals 32. Divide both sides by 8, so x equals 4. So my first number equals 4. My second number equals 4 times 7, right? Because, oops, that's not the right pen. It's x times 4, right? So 4 times 7 is 28. Alrighty. So the two numbers are, therefore, the two numbers are 4 and 28. And you can check that. 4 plus 28, does it equal 32? Why, yes, it does. Okay. Now, we also have coin and money problems, so we have to think about our coins and how much they're worth. So what do the following words mean as a decimal? Well, a penny would be 0.01. A nickel would be 0.05. A dime would be 0.01. A quarter, 0.25. A loonie would be 1.00. And a toonie would be 2.00. They are precise values. And this is thinking about dollars, right? Okay. Now, and how we express money. A laundromat accepts quarters and loonies. There are an equal number of quarters and loonies, totaling 11.25. How many of each coin is there? So we're going to say, let x equal the number of quarters and the number of loonies, because they're the same. So, if I have quarters times my x, so it'll be 0.25x, plus loonies times my x, so that would be 1.00 times x. They total 11.25. Okay? So, just so we know, this is quarters, and this is loonies. Okay? And that's how much they are in monetary value. So I can add those together and I get 1.25x equals 11.25. Now to solve, I divide both sides by 1.25 and I get x is equal to 9. So there are 9 quarters and 9 loonies. Now, how much, this is how many of each coin there are, right? If they were saying how much it is in money, we can also calculate that, right? So for quarters, it's 9 times 0.25, which works out to 2.25. And for loonies, it's it's 9 times 1, which is $9. And you can do that, if you add that up, you'll get 11.25. Okay? But this is how many of each coin is there, not how much money is there in coins. Okay? So 9 is actually our answer. Alrighty? I have 15 more dimes than nickels. If I have $2.55, how many nickels do I have? Okay, so if I say, let x equal the number of nickels, then x plus 15 equals the number of dimes, right? This is my total amount. So, value for nickels, if we remember our decimal, is 0.05, and for dimes, it's 0.10. So, I'm going to have 0.05x plus 0.10 times x plus 15 for my dimes, and they total $2.55. Okay, so in order for me to solve this, I'm going to have to distribute, right? So I'm going to have, 0.05x plus 0.10x plus, 15 times 0.1 is 1.5. Okay, I'm going to combine my like terms. So I'm going to have 0.15x plus 1.5 equals 2.55. And I'm just going to subtract 1.5 from both sides. 0.15x will then equal 2.55 minus 1.5, which is 1.05. And then I'm going to divide both sides by 0.15. Sorry, I'm going to have to scooch it over here, which is equal to x equals 7. So from that, I have, I scooched up, didn't I? So I have 7 nickels, and then I have 7 plus 15 dimes, which is 22. So, therefore, I have 7 nickels and 22 dimes. Now I just wanted to know how many nickels, but you can always give extra information, right? And you can also from that figure out how much money you have. If it asks that, like how much money do you have in nickels, you would go 7 times 0.05, but it hasn't asked for that. Okay, so the big thing is really taking your time. Take your time on the translation because you know how to solve the equations. Okay, and then once you do that solves a lot of your problems. Okay?